Next after the esophagus is the stomach. There are 4 different regions of the stomach that you need to know. You have the cardia, which is when we first get into the stomach, named because it's kind of near the heart. This cardiac sphincter, or the lower esophageal sphincter, allows food to enter into the cardial region. Located inferior to the diaphragm and above and to the left of the cardia, so above and to the left. We're looking at it from a different view here, but this is left side of the stomach is the fundus, and below the fundus is the body, and that connects the stomach, that's the main part of the stomach, if you will. And then connecting the stomach to the duodenum is this 4th region, the pylorus, and this pyloric sphincter is the actual connection to the duodenum of the small intestine. So the smooth muscle, the pyloric sphincter is consisting of smooth muscle, so it's not voluntary. And in the absence of food, the stomach deflates inward, so it kind of goes in on itself, and the mucosa and submucosa fall into large folds called rugae. So you can see it circled here. That's what these folds are. So if I ever ask you about folds in the stomach, the answer is rugae. Looking at the histology of the stomach, the wall of the stomach consists of the same layers as the rest of the alimentary canal, but with adaptations to the mucosa and muscularis layers. Muscularis layer, like I already said, has that extra oblique layer, and it helps vigorously churn food mechanically, breaking it down into smaller pieces. The stomach's mucosa's epithelial lining consists only of surface mucus cells, which secrete protective coat of alkaline mucus, which is really strong or helps to level out the acidity of the stomach bile so it doesn't digest itself. And in a large number of gastric pits, these little indents into the epithelia of the stomach, these gastric pits dot the surface of the epithelia and are the entry points of gastric glands that secrete gastric juice. Inside the gastric glands are a number of different cells that secrete a variety of different substances, such as hydrochloric acid, mucus, pepsinogen, and different hormones. One major component that I want you to know is pepsinogen, which when it's released and exposed to hydrochloric acid is converted to pepsin to enable the digestion of proteins. The stomach needs to be regulated based on the different secretions that can occur throughout time. So this is controlled by nerves and hormones. Stimuli in the brain, stomach, and small intestine activate or inhibit gastric juices production. And this is why the 3 phases of gastric secretion are called cephalic, or head, brain area, gastric, relating to the stomach, and intestinal phases. However, once gastric secretion begins, all 3 phases can occur simultaneously. The cephalic phase, or reflex phase if you will, is relatively brief, and it takes place before food enters the stomach. It's initiated by smell, taste, sight, or even the thought of food, triggering it. For example, when you bring a piece of sushi to your lips, impulses from receptors in your taste buds or the nose are relayed to your brain, which returns signals that increase gastric secretion to prepare your stomach for digestion. This enhanced secretion is a conditioned reflex, meaning that it occurs only if you like or want a particular food. This is why depression and or loss of appetite can suppress this reflex and make you not hungry per se. The gastric phase lasts about 3 to 4 hours and is set in motion by local neural or hormonal mechanisms that are triggered by the entry of food into the stomach. For example, when your sushi reaches the stomach, it creates distension that activates stretch receptors in the stomach. This then stimulates parasympathetic neurons to release acetylcholine, which then provokes increased secretion of gastric juice. Partially digested proteins, caffeine, and rising pH stimulate the release of gastrin from enteroendocrine cells, which in turn induces parietal cells to increase their production of hydrochloric acid. and which is needed to create the acidic environment for conversion of pepsinogen to pepsin so that we can digest proteins. Additionally, the release of gastrin activates vigorous smooth muscle contractions, but it should be noted that the stomach does have a natural means of avoiding excessive acid secretion and potential heartburn. Whenever pH levels drop too low, cells in the stomach react by suspending hydrochloric acid secretion and increasing mucus secretions. So it does have a natural control over its acidity. The intestinal phase of gastric secretion has both excitatory and inhibitory elements. The duodenum has a major role in regulating the stomach as the stomach is emptying. So when partially digested food fills the duodenum, intestinal mucosal cells release a hormone called intestinal gastrin, which further excites gastric juice secretion. This stimulatory activity is brief, though, because when the intestine distends with chyme, or stretches with the chyme that's entering the intestine, the enterogastric reflex inhibits secretion. And one of the effects of this reflex is to close that pyloric sphincter, which blocks additional chyme from entering the duodenum. And this is essential because if we unloaded everything in the stomach all at once with this activation, we would have too much in this intestine to be able to absorb it all effectively. A little bit at a time allows us to absorb as much nutrients as possible by exposing as much of that to as much surface area as we can throughout. So a little bit at a time, just dumps a little bit of liquid in there at a time, and then it inhibits it, and then when it's done absorbing, then it does it again. All right. The digestive functions of the stomach, it has mechanical and chemical digestive functions. When it comes down to the absorption, it does absorb a little bit, such as alcohol and aspirin, but a mixing wave is a type of churning, if you will, for mechanical digestion, and this initial mixing is very gentle, but followed by more intense waves and starting at this body of the stomach and increases in force as they reach the pylorus. But the fundus plays an important role too because it stores both undigested food and gases that are released during the process of chemical digestion. And food can sit in the fundus of the stomach for a while before being mixed with chyme. And while the food is in the fundus, the digestive activities of salivary amylase continue until the food begins mixing with the acidic chyme. Ultimately, these mixing waves incorporate the food with the chyme, the acidity of which inactivates salivary amylase and activates lingual lipase, which can break down lipids for us. The breakdown of protein is going to be accomplished when hydrochloric acid and pepsinogen come in contact, activating that pepsin. And the stomach also secretes intrinsic factor, which is absorbed in intestines. This helps produce mature red blood cells as well as maintain normal neurological functioning. The contents of the stomach are completely emptied into the duodenum within 2 to 4 hours after you eat a meal. And different types of food can take different amounts of time to process, such as carbohydrates emptying the fastest, and then high protein foods take a little bit longer, and then meals high in triglyceride content, fats, take the longest. And since enzymes in the small intestine digest fats slowly, food can stay in the stomach for 6 hours or longer when the duodenum is processing fatty chyme. However, this is still a fraction of the 24 to 72 hours that full digestion typically takes from start to finish. Okay, so now we get to the small intestine. Chyme released from the stomach now enters into the duodenum, which is the first part of the intestine. And the duodenum is going to be an area where a lot of digestive enzymes are secreted by accessory organs, and so there will be the greatest amount of digestion occurring in the jejunum. The duodenum. The jejunum is the greatest site of absorption. Similar to the duodenum, it is right after, it's very close in proximity to the duodenum compared to the ileum, which is the longer portion, which is just kind of carrying or absorbing whatever is left after the jejunum has not absorbed it. So again, not only is this where the most digestion is occurring, it's also where practically all absorption is occurring. the longest part of the alimentary canal is this small intestine, and it's about 10 feet long, and that makes it about 5 times longer than the large intestine, which makes you probably wonder, why is it called small? Well, its name is just based off of its smaller diameter compared to the large intestine. But the duodenum, again, is the beginning, then receiving small amounts of chyme at a time from the stomach. It's the shortest section and receives secretions from the liver and pancreas. And the jejunum is the middle section, leading to the longest portion of the ileum, which then leads to the cecum of the large intestine. When it comes to the histology of the small intestine, the wall is composed of those same 4 layers that is typical of the rest of the alimentary canal, but 3 features of the mucosa and submucosa are unique. These features increase the absorptive surface area of the small intestine more than 600-fold, including circular folds, villi, and microvilli. The circular folds are a deep ridge in the mucosa and submucosa, so you can kind of see them here. These deep ridges, kind of like the rugae of the stomach actually, but these deep ridges cause the chyme to spiral through the small intestine rather than move in a straight line. And this spiraling slows the movement of chyme and provides the time needed for nutrients to be fully absorbed. Within these circular folds are small hair-like vascularized projections called villi, so that these are villi here, and they're vascularized because they have lymphatic vessels and veins and veins and arteries supplying them. The mucosal epithelium, primarily composed of absorptive cells, covers the villi, so you can see these epithelial cells, these simple columnar epithelial cells lining these villi, and they extend off of the absorptive cells in a combined microscopic appearance of mass of bristles. And these bristles on the edge of these epithelial cells, you can't see them here, but if you take a look closer, are called the microvilli. And these bristles are characterized by higher surface area being provided so that we can increase our absorption rate. And this is also known as the brush border. These goblet cells help contribute to mucus being secreted to help especially the duodenum, where there's acidic chyme coming in from the stomach, to not get digested. So these goblet cells, the mucus helps so that protect the lining of the intestines from the acidity of that stomach chyme. And there are other intestinal juices that we're not going to go over, but just understand the intestines release their own intestinal juice that help level out that pH of the acidity of that chyme from the stomach. Excuse me. The movement of intestinal smooth muscles includes both segmentation and a form of peristalsis called migrating motility complexes. If you could see into the small intestine when it was going through segmentation, it would look as if the contents were being shoved incrementally back and forth as the rings of smooth muscle repeatedly contract and relax. Segmentation in the small intestine doesn't force chyme through the tract. Rather, it combines the chyme with digestive juices and pushes food particles against the mucosal lining so that they can be absorbed. When most of the chyme has been absorbed, then small intestinal wall becomes less distended, right? There's less food in there because nutrients are being absorbed. And at this point, the localized segmentation is replaced by transport movements. These transport movements are called migrating motility complexes. These complexes, which start in the duodenum, force chyme through a short section of the small intestine and then stop. The next contraction begins a little bit farther down and then stops again, forcing chyme a bit farther through the small intestine, bit by bit. This takes about 90 to 120 minutes until it finally reaches the ileum. The digestion of proteins and carbohydrates, which partially occur in the stomach, are completed in the small intestine with the aid of intestinal and pancreatic juices. Lipids arrive in the intestine largely undigested, so much of the focus here is on lipid digestion, which is facilitated by bile and also pancreatic lipase. Moreover, intestinal juice combines with pancreatic juice to provide a liquid medium that facilitates absorption, and the intestine is also where most water is absorbed via osmosis.